morning, welcome back. Yeah, so today's actual lesson is, I'm hoping, delightfully simple relative to all that stuff you just did with the double replacements. Also, part two, if you are like swimming in double replacement stuff, take some extra time today. That's totally fine. We would whiteboard game that until you were sick of it if we were all together in the same room. Because it is tricky. That's one of the trickier things in this unit is the double replacement reactions. So for today, we're going to do something a little bit lighter. We are going to figure out solubility. Is it soluble? Is it soluble? And you may be wondering, what does soluble even mean? Sounds kind of like a word that you probably already know somewhere in your life. I'm also waiting for my camera to focus. Maybe not. Solubility, is it soluble? Does it dissolve? Is really your big question here. Will it dissolve? And specifically in the universal solvent, the thing that most things will be dissolved in, if they're dissolved in anything at all, does it dissolve in water? Hey, bonus. Okay, so does it dissolve specifically in water? Great, that's your question. Many salts do, some do not. I'm not going to take you real deep on like why, although if you want that next level, here is your answer. If the salt itself, if the ions are similar to water in charge and in size. So water is H2O, just one hydrogen, try again, two hydrogens, one oxygen. Pretty small. Water is kind of a tiny little compound, actually. So things that are closer to water in size, so like smaller things, and closer to water in charge. And you're like, duh, it's neutral. They're all neutral. You are correct. They are all neutral. I'm going to take you back to week 8 of last quarter, which was right before we all left each other, sadly. When we were doing all that shape stuff, and you were like holding those tetrahedrons in your hands, and you were thinking about how molecules have shape. Water has a shape. It's that tetrahedral shape, and water has two sides that are atoms and two sides that are these lone pairs, and it makes that shape that we call the bent line. It is bent line. But you, in your brain, you know that there's a tetrahedron hiding in there. There's a four-sided, three-dimensional thing. On one side, there's a whole heck of a lot of electron density. There's a lot of negative over on that side. And a whole bunch of, you've got 2 extra protons hanging out on this side. There's relatively more like proton density over here. This is kind of your slightly positive side over here. This is your slightly negative side over here. So water actually is fairly charged. If you want to take physics, we will do some static electricity stuff. You can actually induce static electricity in water just because of that polarity of the molecule. That's polar. You've got one side that is different from the other side. And there you go. So I did it. This is actually the background of like why some things dissolve and some things don't dissolve. So if you're closer to water in size, you're tiny, or closer in charge with this pretty strong charge, things like water will dissolve in water. Things unlike water will not dissolve in water. That makes sense. The other way that you are welcome to do this throughout the entire quarter, if we were in class together, you would have, in quarter 2, you would have a periodic table stapled to, okay, so the periodic table that you use in quarter 2 literally has the polyatomic ions on the back. You are like so sick of these by now that you're just getting started. Yeah, but you're used to your polyatomics, This stapley thing would have on the very next page. Oh, ta-da. Okay, so I'll link this to you also. You can also put a bookmark on this, although we'll use it less often. However, for today and tomorrow, this is what you are looking at. Here's a table with a whole bunch of stuff on it. Again, though, you don't memorize this. I mean, you'll see some patterns here. You're gonna see like a side of this diagram that is super similar, and a side that, like, there's some things that. But before I get into, let's figure out how to read it first. You'll notice, if we were in class, I'd hand this to you and say, what do you see? You will notice that along the top, you have cations. Okay. And you may even notice that as you go across these cations, you've got +1 stuff over here. So +1, +1, +1, group 1. Okay, so these things are all +1. You've got some +2 stuff over here. And then your aluminum, your transition metals. So there's some like organizational stuff to it. Down the side is all of your anions, all of your negatively charged things. And again, these are your single atom ions, your monatomic ions. Here you've got some polyatomic ions. They kind of increase in complexity as you go down, just like they increase in complexity as you go across. Just kind of some like navigational tips on getting around this page. The version that I'm going to link to you is also in color, which is kind of cool. So you get like the updated, even better than printed version, so that's cool. There are 4 options for what you might be seeing in any given box. I should back up. Each box is a salt. So if you had, for example, some sodium hydroxide, there's your sodium, there's your sodium column. Make some mental notes about what you notice about if sodium dissolves in water. There's a pattern. There's your sodium column. Here's your hydroxide row. Positive stuff, negative stuff. There's your sodium. There's your hydroxide. Boom. If you want to know if sodium hydroxide dissolves in water, it is SOL. Oh, I don't think I've ever said that quite like that before. Great. Or Sol, you can use Sol, whatever. Go down here to your key, SOL, Sol, different than you might expect. Or perhaps exactly what you would expect. SOL is soluble. Makes sense. If it is Sol is slightly soluble. They're just trying to condense their consonants here. Right, so if you've got something that's slightly soluble, it means it dissolves sometimes. Tomorrow we're going to take another step into why or why not. Like, what does that mean that it is slightly soluble? Don't worry, we'll go there also. But for today, anything that they ask you today, or if I'm telling you to look it up on this page, slightly soluble is a totally legitimate answer. Just to finish us up here, insol is insoluble. That means it does not dissolve. If it is insoluble, it does not dissolve, whereas soluble means it does dissolve. And then some of these Flynn has left blank for us. Compound does not exist. I find this a pretty questionable answer personally, but I really like Flynn, so we'll go with it. So if I give you a question and the box is blank, write compound does not exist, and we'll just go with it. Okay, and that is it for today. All you have to do in today's stuff is figure out how to read this table. Like I said, it's real nice compared to yesterday. We'll do some examples on the next page, kind of like usual. And so for today also, you're going to do this and some practice questions and watch a lab. So we're going to take this like another step from this lovely page of letters, which someone else has given to you, and actually watch it. We would do this lab if we were together. I'm going to give you 4 links. You're going to choose at least one and watch that one. You're welcome to watch more than one, but choose at least one so that you get like visually in your mind a picture of what it means for something to be soluble versus insoluble. Alright, I'm going to do some examples in the next video.